So hello, a very good afternoon to all. Right? सबको मेरी स्क्रीन विजिबल है क्या? And I'm audible also. एक बार confirm कर दो फटाफट. Then we are going to start our session. ठीक है? So this is the second class of this chapter, that is the mole concept, right? So in the first class we already discussed some important thing related to the mole concept. So this is the second class. So I'm Vivek Tiwari from the Department of Chemistry, right? And this is the in this session we are going to do the mole concept crash course because we yes. Yes. So my voice is visible to all of you, right? So in this course basically more concept हम लोग crash course की तरह कर रहे हैं, ठीक है? इसको जल्दी से finish कर रहे हैं and covering all the important topics, more focus on solving numerical, right? Because this chapter is totally numerical based. So if you know the concept, then you can easily apply this concept to solve numerical, right? So let's start with the today session. So in the previous session, we already discussed about the various things regarding what is the limiting region concept and how will you solve the problem related to this, right? Now in this, we are going to see the calculation involving the percentage. So many times the questions were coming in which they are asking about the percentage. So how will you solve this question? In the question in which they are asking the percentage. Okay? So basically in general, when the reaction is carried out in the laboratory, we do not obtain actually the theoretical amount of the product, right? So जब भी हम किसी चीज के एक्सपेरिमेंट करते हैं तो वहां पे हम लोग को एकदम theoretical अमाउंट ऑफ प्रोडक्ट नहीं मिलता है जितना हम लोगों ने सोचा था कि हाँ भाई इसको इतना मिलना चाहिए, तो या तो उससे कम भी मिल सकता है या उससे ज्यादा भी मिल सकता है, मतलब एक्जेक्टली उतना नहीं मिलता है. Yani the amount of product that actually obtained is called actual yield. So whenever they are asking about the actual yield, what do you mean by this term beta actual yield? That is the amount of product that is actually obtained is called actual yield. And knowing the actual yield and the theoretical yield, the percentage yield can be calculated, right? So if you know the theoretical yield, that is before the experiment, theoretically this amount will form, right? And after the experiment, you'll get the exact amount what is formed in the particular reaction. So knowing the actual yield and the theoretical yield, the percentage yield can be calculated by using the formula. So what formula basically we are using for calculating the percentage yield? So for calculating the percentage yield, we are using the formula like actual yield upon theoretical yield multiplied by 100, right? So this is the formula that we are going to use, that is actual yield upon theoretical yield into 100. So this formula we use for calculating the percentage yield. So I hope यहाँ तक सबको clear है. How will you calculate the percentage yield? परसेंटेज यील्ड मीन्स होता ही यही है कि कितना बना है हम लोग एक्चुअल में, कितना परसेंट प्रोडक्ट बन रहा है, कितना परसेंट हमारा प्रोडक्ट बन रहा है जब हम उसका रिएक्शन करा रहे हैं. ठीक है, तो परसेंटेज यील्ड इज इक्वल टू एक्चुअल यील्ड जितना बना है डिवाइडेड बाई जितना बनना चाहिए था थ्योरेटिकल यील्ड एंड मल्टीप्लाई बाई 100. सो बाई दिस फॉर्मूला वी गेट द परसेंटेज यील्ड. We are going to solve one numerical related to this topic as well, so that our concept become crystal clear. यहाँ तक किसी को कोई डाउट है तो बताओ जल्दी फटाफट. Anyone having any kind of doubt till? No? Shall we move? Sure. No. So this question is related to this concept, right? So this is a very important question. So in this question, they're asking for the reaction of a calcium oxide with the hydrochloric acid, calcium chloride plus H2O is formed. So 1.2 gram of calcium oxide is reacted with the excess of hydrochloric acid and 1.85 gram of calcium chloride is formed. So what is the percentage yield? So they are asking what is the percentage yield of this reaction. So let me write the equation first. So in this they are asking calcium chloride and they react with 2 mole of HCl to form CaCl2 plus H2O. They form CaCl2 plus H2O. So we know that 1 mole of calcium chloride and they will form 1 mole of calcium chloride. So 1 mole of calcium oxide react to form 1 mole of calcium chloride. So we can say that now calcium chloride having molecular mass what beta? So calcium oxide having molecular mass what beta? That is 56 gram. How will you calculate? Because we know calcium molecular mass is 40 and for oxygen the molecular mass is 16. So total 56. And here we also calculate in case of Cl2 70 and this is 40. So this will comes out to be calcium 40 and this is 70, 35.5, 71, right? So 71 plus 40. So it comes out to be 1 gram. ठीक है 11 gram. So from this equation, it is clearly we can see that that is 56 gram of calcium oxide. ठीक है 56 gram of calcium oxide produces. So 56 gram of calcium oxide produces how much amount of CaCl2 beta? That is 111 gram. ठीक है that is 111 gram of CaCl2. तो ये तो एकदम क्लियर है इक्वेशन देख के पता लग गया कि 56 ग्राम ऑफ कैल्शियम ऑक्साइड प्रोड्यूसेस 111 ग्राम. Now, so how many gram of calcium oxide is given in this question? That is 1.23 gram. So 1.23 gram. So 1.23 gram of calcium oxide theoretically कितना प्रोड्यूस करना चाहिए? So अगर 56 ग्राम इतना कर रहा है तो 1 ग्राम कितना करेगा? 1 ग्राम करेगा डिवाइडेड बाय 56. So 1.23 ग्राम कितना करेगा? So this is what the question is. ठीक है? So ये निकल के आ गया है 2.43 ग्राम. So this is 2.43 gram. So in actual, we can say that 1.8 gram of CaCl2 formed, right? So actual 1.85 gram of CaCl2 formed, but theoretically जब यहाँ पे calculate किया तो कितना बन रहा है? 2.43 gram. So now can you calculate the percentage yield? समझ आ गया कि actual lab में कितना बन रहा है? ये बन रहा है 1.85 gram of calcium chloride. एंड जब हमने थ्योरेटिकल कैलकुलेट किया तो कितना बना? दैट इज 2.43 ग्राम, राइट? सो व्हाट इज द परसेंटेज यील्ड? सो वी कैन एक्चुअली कैलकुलेट परसेंटेज यील्ड बाय यूजिंग द फॉर्मूला. प्रीवियस फॉर्मूला क्या पढ़ा था परसेंटेज यील्ड का? दैट इज परसेंटेज यील्ड इज इक्वल टू व्हाट? दैट इज एक्चुअल यील्ड अपॉन थ्योरेटिकल यील्ड. सो दैट इज एक्चुअल यील्ड अपॉन थ्योरेटिकल यील्ड. So actual yield दे रखा है 1.85 and what is the theoretical yield? Theoretical yield is 2.43 multiply by 100. So you'll get the answer, right? So कितना आ रहा है? लगभग 76.1%. So which option is correct बेटा? Option number A. सबको समझ आया वाला क्वेश्चन? जल्दी बताओ फटाफट. Everyone got this question?
Yes, sir.
Yes, good बेटा. So this is how you actually calculate the percentage yield. Chaliye. Now, next the calculation involving percentage purity. So in this we are going to calculate the percentage purity. So in this type of calculation, depending upon the mass of the product, the equivalent amount of the reactant present can be determined with the help of the chemical equation. Right. So this is the type of calculation depending upon the mass of the product. So it depends upon how much product will form. Depending upon the mass of the product, the equivalent amount of the reactant present can be determined with the help of a chemical equation. So knowing the actual amount of the reactant taken and the amount calculated with the help of a chemical equation, the percentage purity can be determined. So what is the formula for calculating the percentage purity beta? That is percentage purity is nothing but this is equal to weight of the reactant required divided by weight of the reactant taken into 100, right? कि कितना weight of the reactant हम लोगों ने starting में लिया था and कितना weight of the reactant हम लोगों को required था. So इन दोनों का ratio multiply by 100, this will give the percentage purity, right? Percentage purity. It is clear from its name also, right? That is percentage purity. That is weight of the reactant required divided by weight of the reactant taken and multiply by 100. So this will give the percentage purity. ठीक है? चलो. The next is calculation involving mass volume relationship. So this is also a very important relation. That is, in such calculation, masses of the reactant are given and volume of the product is required. Or we can say that when the volume is given, the masses of the product reactant will require. Right. So both cases are possible. So in such calculation, masses of the reactant are given and you need to calculate the volume of the product or vice versa. Right. As the 1 mole of a gas, we all know that the 1 mole of a gas occupy 22.4 liter at the step P. that is the standard temperature and pressure. Thus the mass of the gas can be related to the volume according to the following equation. So we all know this, PV is equal to nRT. अगर नहीं पता है तभी इसको याद रखो बेटा. Later in the states of matter we are going to discuss this question as well, right? That is, what do you mean by this? PV is equal to nRT. In states of matter also we are going to see this ideal equation, right? So PV is equal to nRT. So we can write now PV is equal to W upon mRT. Why this W? Because this represent mass and this M represent the molecular mass. Okay? This represents the molecular mass. So we know that we can write number of mole is equal to mass divided by the molecular mass. So this is how we can write, that is PV is equal to W upon M into RT. ठीक है, चलो. So एक क्वेश्चन करते हैं इसके ऊपर और फटाफट समझने की कोशिश करते हैं कि whenever such type of questions are coming, how will you solve? ठीक, चलो. So in this question, a vessel contain 1.6 gram of dioxygen at STP, right? That is, temperature is 273.15 and the pressure is 180. Now the gas is now transferred to the another vessel at a constant temperature. So we have a two vessel. Let us assume that one vessel is this and another vessel is this. So this is the number one vessel and this is number two vessel. ठीक है? So a vessel contain 1.6 gram of dioxygen at STP. This gas is now transferred to the another vessel, right? So यहाँ से gas transfer हो रहा है another vessel, इस vessel, ठीक है? Gas transfer हो रहा है. कौन सा gas transfer हो रहा है? Oxygen, ठीक है? तो कौन सा gas transfer हो रहा है बेटा? Dioxygen, O2, ठीक है? The gas is now transferred to the other vessel at the constant temperature. So their temperature remains same. यानी T1 is equal to T2. Where pressure become half of the original pressure. यानी यहाँ पे अगर प्रेशर P था तो यहाँ पे प्रेशर कितना हो गया बेटा? P/2. ठीक है? So where pressure become half of the original pressure, the volume of the new vessel and the number of molecule of dioxygen are. So you have to calculate the V2, right? If this is V1, then you need to calculate the V2, and also you need to calculate the number of the molecules. So this is what the question asks basically, right? And the temperature is given, that is T1 is equal to T2, and this is given 273.15 Kelvin. So both the temperature are equal and this O2 gas is transferred. So mass of this O2 gas is also given, that is 1.6 gram. And we need to calculate the volume and the number of molecule of dioxygen. ठीक है, यही हम लोगों को calculate करना है. So I hope सबको क्वेश्चन समझ आ गया होगा कि क्या है क्वेश्चन में और क्या पूछ रहा है हम लोगों से. Got it? सबको समझ आ गया क्वेश्चन? चलो. अब we all know that क्या पता है हम लोगों को कि अगर मैं बोलूं 1 मोल, राइट? सो 1 मोल को कैसे लिख सकते हैं बेटा हम, और ध्यान से. So we can write 1 mole. We all know that. What is 1 mole? So 1 mole is equal to 22.4 liter, right? At STP. We all know this thing, right? That is 1 mole is nothing but it is equal to 22.4 liter at STP, right? Similarly, हम लोग और क्या लिख सकते हैं बेटा कि 1 mole of oxygen, yeah, this is the 1 mole of O2 is equal to 22.4 liter at STP. Similarly, we can also write 1 mole of O2 is also equal to their molecular mass, that is 32 gram. ठीक है, लिख सकते हैं. It means we can write as 32 gram, that is 32 gram, right? That is 32 gram of oxygen occupies, right? 32 gram of oxygen occupies 22.4 liter of volume at STP. लिख सकते हैं, that is 32 gram of oxygen occupy 22.4 liter of volume at STP. So in this question they're asking 1.6 gram. So 1.6 gram कितना occupy करेगा? That is 22.4 and divided by 30 to get for the 1 gram. and for the 1.6 gram multiply by 1.6. So on solving you will get 1.12 liter of volume. So this volume is comes that is V1. So V1 कितना निकल के आ गया? That is 1.12 liter. So this is the value of V1. ठीक है, everyone got it? So this is the value of V1, that is 1.12 liter. Now we know that P2 is equal to P1 का half है. That is P1 by 2. So what is P1? That is 1, and 1 divided by 2 is equal to 0.58 here. Now we just need one quantity, that is V2. ठीक है? That how will you calculate this V2? ठीक है, V2 को तो निकालना है, calculate. Now one important note is given. That is PV is equal to nRT, right? So when we use this formula, basically in this the temperature is also constant. So if this N is already constant because this is the mode, R is also known as the universal gas constant. Now if the temperature is also constant, then we can write this equation as PV is equal to constant. And if the PV is equal to constant, it means P1 V1 is equal to P2 V2, right? Now from this equation, can you calculate V2? Obviously we can calculate, because V2 is nothing but this is equal to P1 V1 divided by P2, right? P1 V1 divided by P2. So what is P1? What is P1? So P1 in this is already given, that is P1 is equal to 1. What is V1? What is V1 beta? So that is given, that is 1.12. And what is P2? That is 0.5. Okay. So on solving, you'll get V2. So on solving, you'll get V2. So V2 comes out to be 2.24 liter. So this is the value of the volume. ठीक है, तो इस तरीके से हम लोग V2 निकाल सकते हैं, वॉल्यूम को निकाल सकते हैं. This is equal to 2.24 liter. So I hope this is clear to all of you. Now they are asking number of molecule of oxygen in the vessel. So the number of molecules, ठीक है, so the number of molecules of oxygen in the vessel. ठीक है, so the number of molecule of oxygen in the vessel you need to calculate. So how will you calculate? That is nothing but is equal to Avogadro number multiply by 1.6 and divided by 30. So that is how you can get the number of molecule of oxygen in the vessel. So anyway, we all know that that is 6.022 10 raised to the power 23. This is 1. This is 1.6. So this is 1.6 and this is 30. So on solving, what you will get, that is 3.011 into 10 to the power 22. Okay, so this is what you get the number of molecule of oxygen in the vessel. So I hope ये दोनों clear हो गया होगा. How will you calculate the volume of the new vessel and how will you calculate the number of molecule of dioxygen. Okay, so this is how you can actually calculate. So which option is correct, beta? Can you anyone tell which option is correct? So we can say that the option number D is absolutely correct. Okay, option number D is absolutely correct for this question. Okay, sure. Now, so this is also a very important PYQ question, right? And this is also related. This is actually a JEE advanced question. Okay, so this is a JEE advanced question which comes on the stoichiometric quantities. So अब देखते हैं कि कैसे करोगे तुम ऐसे क्वेश्चंस को. What is the step for solving such type of questions? ठीक है, कि कैसे करने वाले हम लोग ऐसे टाइप के क्वेश्चंस. फटाफट देखिए. So actually in this question they are asking, in the chemical reaction between the stoichiometric quantities KMnO4 and Ki in a weakly basic solution, what is the number of moles of I2 released for the 4 moles of KMnO4 consumed? अगर 4 moles KMnO4 का consume हो रहा है, then how many moles of I2 released? ठीक है, तो दिस इज व्हाट वी आर नीड टू कैलकुलेट इन दिस क्वेश्चन। ठीक है, चलो। In the chemical reaction. So let me first write the equation corresponding to this given equation. That is whenever KMNO4 react with Ki. So whenever the KMNO4 react with Ki, what they form? They form MnO2 plus I. ठीक है, so whenever KMNO4 react with Ki, it will form MnO2 plus I. Now here we can calculate in this oxidation state of Mn is 8 plus 1 minus 1 7. That is plus 7. And here the oxidation number is plus 4. Okay. So we can say that what is the N factor in this case? So N factor 3. Okay. N factor is 3. What is N factor? We can just calculate by use what is the difference between the oxidation and reduction. So in this case, the N factor is 3. Always remember this thing. Because in KMnO for the oxidation state of Mn is plus 7, or in MnO2, the oxidation state of Mn is plus 4. So the N factor comes out to be 3. Now, on the similar basis, when the 2I negative, check it, and this 2I negative will give I2. So what is the N factor for I2? So here N factor is 2. Because the -1 पे है, तो -1 से 0 and 0 से फिर 1. So we can say that the N factor is 2. ठीक है? Now, this KMNO4 react with Ki. सब कुछ क्वेश्चन में given है. React with Ki. What they will form? They will form MnO4 plus I2. And here also the N factor is 2. N factor is equal to, ठीक है, N factor is equal to 2. And here N factor is equal to what? Can anyone tell me for this side? What is the N factor? N factor they are asking. So here the N factor is, in this case, the N factor is 2. So in this case also, if you want to calculate the N factor, then N factor is equal to 3. N factor is 3. So this is how you can actually calculate this. Now we can write that is the equivalent of KMNO4, equivalent of KMNO4 is equal to equivalent of I2. So what is the equivalent of KMNO4? That is N factor multiplied by the number of moles. Here also N factor and multiply by the number of moles. Okay, multiply by the number of moles. So we can say that the 3 mole of KMNO4, we can write as the 3 mole of KMNO4. This will require 2 moles of I2. 2 mole of I2, right? So 3 mole of KMNO4 require 2 mole of I2. So we can say that if 3 mole is required this much, then the 4 mole of required how much? If the 3 mole of KMNO4 required 2 mole of I2, then if you want to calculate for the 4, so 3 into 4 is equal to 2 moles of I2. Okay, so mole of I2 comes out to be 6. So this is what they are asking the question. That is, you need to calculate the mole of the I2. Rest all things are given in the question itself. Now, the next question is, if the value of the Avogadro number is 6.023 into 10 to the power 23, and the value of the Boltzmann constant is 1.380 into 10 to the power minus 3, 23, then the number of significant digit in the calculated value of the universal gas constant, right? You have to calculate for the universal gas constant. That is how many units come. ठीक है, चल. So we are using the formula, right? Like R is equal to K and A, right? R is equal to K and A, where K is the Boltzmann constant and N is the Avogadro number, right? So how will you calculate R? So we can calculate R by putting the value 1.380 into 10 की power minus 23. This is the value of K. What is Avogadro number? 6.023 into 10 raised to the power 23. ठीक है, so that is 1.380 into 10 की power minus 23 multiplied by 6.023 into 10 की power 23. So this is how will you calculate the value of R, which on solving comes out to be 8.312. We already know this thing. R is equal to 8.314 into 10 की power minus 3 in terms of kilojoule, or 0.0821 in the terms of joule. Since K and Na both having the four significant figures, यहाँ पे कितने significant figures हैं जल्दी बताओ. फोर significant figure है. यहाँ पे कितने हैं? तो यहाँ पे भी कितने हैं बेटा? फोर significant figures है, right? तो दोनों में कितने कितने significant figures है? फोर फोर. ठीक है. So the value of R is also rounded up to a four significant number. ठीक है, इसीलिए इसको भी हमने फोर significant number तक rounded कर दिया. So when the number is rounded off, the number of the significant figure is reduced. So the number of the significant figure, we can say that this is 4. तो कितने number of significant figures बन रहे हैं R के? So we can say that 4. So इसके भी 4 ही significant number बन रहे हैं. So this question is from the significant figures. That is how will you identify the significant figure? This thing you already study in your physics class also. What about the error, different types of error and the significant numbers? चलो, ये क्वेश्चन कौन करके दिखाएगा? तुम लोगों में से कोई क्वेश्चन करना चाहता है ये वाला? जल्दी बता दो फटाफट. Which has the maximum number of atoms? So I'll give you a 15 second to solve this question, because this is a very simple question. So you have to calculate which has the maximum number of atoms. बताओ जल्दी. Which has the maximum number of atoms? That is 24 gram of carbon 12, 56 gram of Fe56, 27 gram of aluminium having atomic number 27, and 108 gram of silver having atomic number 108. बताओ, which has the maximum number of atoms? We all know that now. How will you calculate? One simple formula, that is 1 mole is equal to molecular mass, and 1 mole is also equal to 6.023 10 की power 23 atoms, molecules और ion. ठीक है, this is how we can also calculate. So just calculate. I'll give you 5 seconds. फटाफट calculate करो. Just मैं charge पे लगा रहा हूँ लैपटॉप, जब तक मैं calculate कर लेना. यस, निकला किसी का? कैलकुलेट किया किसी ने क्या? किसमें आ रहा है मैक्सिमम नंबर? देखो, 1 मोल इज इक्वल टू मॉलिकुलर मास एंड 1 मोल इज ऑल्सो इक्वल टू 6.023 into 10 की पावर 23 atoms, molecules or ion. So we can say that for the carbon, that is molecular mass of carbon is what? Molecular mass of carbon, that is 12. So we can say that now, that if the 12 gram contain this much of atom, so 24 gram contains how much beta? 24 gram contains 2 Na. Na means 6.023 into 10 to the power 23. Similarly, atomic mass of iron is 56 and 56 gram also. So this 56 gram contain only Na number of atoms. Aluminium having atomic mass or molecular mass 27 only. So this aluminium contain 27, which is equal to Na only. Okay? And silver. So silver having the molecular mass 108. So they will contain Na. So which will contain maximum number of the atom? Obviously, carbon, because they contain twice the Avogadro number, that is 12.046 into 10 to the power 23 atoms per 24 gram. Okay? So this is how you can actually calculate the maximum number of atoms. So I hope ये clear हो गया होगा सबको. चलो. Now, this question is also important. ये सभी questions advance में आए हुए questions हैं. So ध्यान से समझो इसको. How many moles of electron weight 1 kilogram? So you have to calculate how many moles of electron. कितने moles of electron को हम बोलेंगे कि ये 1 किलोग्राम होंगे. ठीक है? तो इलेक्ट्रॉन का मास कितना कम होता है? That is 9.31 into 10 की पावर -31 किलोग्राम. So आपको बताना है how many moles of electron weight 1 kilogram. ठीक है? तो चलो देखते हैं फटाफट. We know that mass of one electron is equal to 9.108 into 10 raised to the power -31 kilogram. ठीक है? This is we know. That is the mass of one electron is equal to 9.108 into 10 to the power -31 kilogram. Similarly, mass of 1 mole of electron, because in the 1 mole, this is a 1 electron, or in 1 mole, how many electrons are there? So in 1 mole, we have a 6.023 into 10 to the power 23 electrons are there. So we can say that mass of 1 mole of, so mass of 1 mole of electrons. So mass of 1 moles of electron is equal to 9.108 into 10 की power -31, and this multiply by the Avogadro number. ठीक है? So mass of the 1 mole of electron is equal to 9.108 into 10 की power -31 into 6.023 10 की power 23. So just solve this. So on solving, what you will get beta फटाफट. So on solving, you will get around, इसको ऐसे ही रहने दो, 9.108 into 6.023, just power को solve कर लो. So this comes out to be 10 raised to the power -8 kilogram. 10 raised to the power -8 kilogram. Right. So this is the mass of 1 mole of electron. This is the mass of 1 mole of electron. Okay. So this is the mass of 1 mole of electron. That is 9.108 into 6.023 into 10 raised to the power -8. Now in this question they are asking the number of moles. So how will you calculate the number of moles of electron that weight 1 kilogram? Right? So we can calculate the number of moles. Right? So how will you calculate the number of moles of electron? This is the mass. So we know that number of moles is equal to mass divided by the molar mass. Right? So we can calculate the number of moles of electron that weight 1 kilogram. ठीक है? जिसका वेट 1 किलोग्राम हो. सो नंबर निकालना है ना, तो मास ऑफ 1 मोल ऑफ इलेक्ट्रॉन इतना आ गया, और 1 किलोग्राम का निकालना है, तो 1 किलोग्राम के अंदर इतने मोल्स, इतने इलेक्ट्रॉन्स ऑलरेडी प्रेजेंट हैं. सो वी कैन कैलकुलेट द नंबर ऑफ मोल्स, द नंबर of moles. So the number of moles of electrons. So the number of moles of electrons that weight 1 kilogram. That weight 1 kilogram is equal to 1 divided by 9.108 multiplied by 6.023 10 raised to the power minus 6. So this is how we can actually calculate. So on solving, what you will get, that is 1.0. So option D. Yes. So option D is the correct answer. ठीक है. तो सबको समझ आ गया होगा कि option D कैसे correct है और क्या value है इसकी. So this is how we can actually solve this question. Okay. So move to the next question. That is question number 9. So what the question asks? An aqueous solution of 6.3 gram of oxalic acid is dehydrated and is made up of 250 ml, and the volume of 0.1 normality NaOH required to completely neutralize 10 ml of this solution. So you need to calculate this. 10 ml of this solution के लिए कितना volume का required होगा. So कैसे कितना होगा भाई फटाफट निकालो. So we know that first of all, what is the N factor of the oxalic acid, right? So you need to calculate the N factor of oxalic acid first. So the N factor for oxalic acid, for oxalic acid. So N factor for oxalic acid. How will you calculate it? We know the formula of oxalic acid. H2C2O4.2H2O. So we know that for the oxalic acid, N factor is equal to 2, right? So for the oxalic acid, we already discussed this thing in the normality. That is how will you find the N factor for the following acid, base or salt, right? So N factor is 2 for the oxalic acid. Clear? Now, we know that what is normality. So normality is equal to weight into 2 into 1000 divided by molecular weight into 250. ठीक है. कैसे निकालोगे जल्दी बताओ फटाफट. How will you calculate this value? Can anyone tell me? Because we know that formula of normality is nothing but mass upon equivalent weight, which is equal to molecular mass upon something. So this is the molecular mass and divided by N factor, that is 2. Now this is same, that is multiplied by 1000 upon my volume. So volume is given 250 ml. So this is how we'll write this formula. That is N is equal to mass, that is weight, multiplied by 2 into 1000 divided by the molecular mass and the 250, that is the solution, right? So this is how we can actually write this. So just put the value. If you put the value, you'll get normality, which is equal to weight 6.3 and 2 into 1000 become 2000 divided by the molecular mass, which is 126, and this is 250. So on solving, you'll calculate the normality, which is comes out to be 0.4. Okay? So this is the normality basically, that is 0.4. Clear है यहाँ तक सबको? How will you calculate the normality? Because we need know the formula of normality. That is normality is nothing but the molecular mass upon me. That is mass of the solid divided by the equivalent mass. Equivalent mass, how will you calculate? Molecular mass into divided by N factor. So here the N factor is 2 and multiply by 1000 upon molecular mass. So this is how we can calculate the normality. So by putting the value, you'll get normality is equal to 0.4 N. Now, from the normality equation, that is N1 V1 is equal to N2 and V2, right? So what is N1? That is 0.4. What is V1? That is 10. What is N2? So this is also given 0.1. Okay? And what you need to calculate, that is V. So on solving, actually you calculate V2 is because V2 comes out to be 0.4 into 10 divided by 0.1. So 4 into 10, that is 40. So 40 ml. So which is the correct answer? That is 40 m. A. So A is absolutely correct answer for this question. ठीक है, समझ आ गया हो सबको? Now the next thing, you need to calculate the normality of 0.3 molar phosphorus acid, that is S3PO3. So you need to calculate the normality of 0.3 molar phosphoric acid. So we know that. How will you calculate normality? So this is a very simple formula. Normality is equal to molarity into n factor, right? So if you know the n factor, then you can easily calculate normality. The molarity is given. So we know that here the formula is phosphorus acid, that is S3PO3. So let me draw the diagram for this. That is B double bond O. Right. And how many O we have? Two O. So we have the two OH and one H. So this is how many replaceable hydrogen is there? That is one and that is two. So only two replaceable hydrogen is there. So N factor is equal to two. ठीक है, ये सब हमने पहले डिस्कस किया हुआ है. So molarity is equal to 0.3 and N factor is 2. So it comes out to be 0.6. So this is a very simple question. That is the normality of 0.3 molar phosphoric acid S3PO. ठीक है, तो आई होप तुम लोग को सबको ये समझ आ गया होगा यहाँ तक बहुत इजी तरीके से. आप कुछ लेटेस्ट क्वेश्चन लेते हैं इसके. These questions were coming in the last year examination, or we can say this year examination only. That is in January 2023, right? So this question is from 13th April evening से. Okay, अप्रैल का क्वेश्चन है ये. तो क्या है क्वेश्चन, ध्यान से समझो. तो क्वेश्चन कह रहा है 1 gram of carbonate on treatment with excess of HCl produce 0.01 mole of CO2. You have to calculate the molar mass of this M2CO3 in gram. So you need to find which metal is this. If you calculate the metal, then you can easily calculate the molecular masses, right? So first of all, you need to identify which metal is this. ठीक है, कि कौन metal है इसमें. So basically, when the carbonate, 1 gram of carbonate, metal carbonate on treatment with HCl. So we have M2CO3 and they treated with 2 HCl, they will form 2 MCl plus H2O plus CO2. So this is the equation. Now from the problem we know that the 1 gram of carbonate produce 0.01 mole of the CO2. So 1 gram of carbonate will treatment the HCl to produce 0.01 mole of CO2. Right. So we can write as 1 mole of M2CO3 produces. ठीक है, 1 mole of M2CO3 produces 1 mole of CO2. 1 mole of CO2 and 1 mole. So 0.01 mole of CO2 present how much? Because in this question they asked 0.01 mole of CO2. So 1 mole of M2CO3 produce this 1 mole of CO2. So we can say that. So 0.01 mole of CO2 mole of CO2 correspond to 0.01 mole of M2CO3. क्या कह रहा है ये कि भाई इक्वेशन लिख दिया और इक्वेशन में साफ साफ गिवन है कि 0.01 मोल ऑफ CO2 प्रोड्यूस करता है 1 ग्राम ऑफ कार्बोनेट, यानी 1 मोल ऑफ M2CO3 प्रोड्यूस 1 मोल ऑफ CO2. सो 0.01 मोल ऑफ CO2 प्रोड्यूस 0.01 मोल ऑफ M2 से. ऑब्वियस सी बात है, दोनों का रेशियो 1 मोल का है ना. तो अगर 1 मोल M2CO3 का 1 मोल ही CO2 बना रहा है तो 0.01 मोल ऑफ CO2 जो होगा वो 0.01 मोल ऑफ M2CO3 बनाएगा. ठीक है, now we can find the molar mass. How? So we can find the molar mass because we know that N, which is equal to mass upon molecular mass. Mass upon molecular mass. If you want to calculate the molecular mass, then it will become mass upon number of chicken, mass upon number of moles. So what is mass? So mass is given, that is 1 gram. What is number of moles? So number of moles is also given, that is 0.01. 0.01 mole. Remember, not we can say that 1 mole or 2 mole. 0.01 mole. So from solving, it is very much clear. It comes out to be 100 gram per mole. So the molar mass of M2CO3 is experimentally 100 gram. तो इसका molar mass कितना होगा? Around 100 gram. Experiment. ठीक है? So I hope this is clear to you. चलो. The next question is that is an organic compound gives 0.220 gram of CO2 and 0.126 gram of H2O on complete combustion. So if the percentage of carbon is 24, then what is the percentage of hydrogen? Okay, then the percentage of hydrogen is dash into 10 to the power minus 1. So you need to calculate this. So 0.22 gram of CO2. So you need to calculate how many percentage of hydrogen is. Okay, chalo. So we know that to find the percentage of hydrogen in the compound, we first need to determine the ratio of the moles of carbon and hydrogen in the product. So basically the moles of CO2 produced can be calculated by dividing the mass with the molecular mass. So moles of CO2 is equal to their mass, that is 0.220 gram divided by the molecular mass 44. So it comes out to be 0.005 mole. Right? Since each mole of CO2 contain 1 mole of carbon. Okay? Since each mole of CO2 contain 1 mole of carbon, therefore 0.05 mole of carbon in the compound. So let us calculate the moles of H2O. So how will you calculate the moles of H2O? Moles of H2O is equal to 0.126 already given divided by 18. So it comes out to be 0.007 mole. Okay? 0.007 mole. Okay? Now let us find a mass of carbon and this thing. So how will you find the mass of carbon, beta? So if you know this, then the mass of carbon. So mass of carbon is equal to mole of carbon into में molecular mass. ठीक है? So mass of carbon is equal to moles of carbon into molecular mass of carbon. So moles we already calculated 0.05 and the molecular mass is no 12. Right? So on solving you'll get the value, that is mass of the carbon. Similarly, mass of hydrogen. So mass of hydrogen. So how will you calculate the mass of hydrogen? So mass of hydrogen is equal to 0.014 mole multiplied by 1.008 gram. Okay? So this is how will you calculate all this thing. Finally, the percentage of hydrogen that we need to calculate is, that is the percentage of hydrogen. So percentage of hydrogen is nothing but is equal to mass of hydrogen. Mass of hydrogen divided by total mass of compound. Total mass of compound. ठीक है? So percentage of hydrogen is equal to mass of hydrogen divided by the total mass of compound. Right? So total mass percentage of hydrogen is 5.6%. कितना निकल गया? Mass of hydrogen is already given. ठीक है? Mass of hydrogen already given है यहाँ पे. Multiply by 100 भी कर देना. So mass of hydrogen is given 0.014 gram. Total mass is also given 0.250 gram into 100. तो ये कितना आ गया? That is around 5.6. ठीक है? तो 5.6 आ गया. Nearest number कितना आ गया? 5.6. We can say that it's equal to 5.6 or. ठीक है? So this is how we can actually calculate this. So हमने बहुत सारे क्वेश्चंस ट्राई किए आज. इस तरह के क्वेश्चंस आते हैं, तुम्हें भी सॉल्व करना है. So these are some homework question for all of you. इसको फटाफट नोट कर लो, इसको ट्राई करना, कोशिश करने की. ठीक है? एक सॉल्यूशन है शुगर का. 200 ग्राम 25% सोल्यूशन, 500 ग्राम में 40% सोल्यूशन में मास है. You need to calculate the mass percentage of the resulting sugar solution. So this is a homework question for you all. This is also a homework question. ठीक है? Like 3 molar solution का NaCl है, तो इसको भी निकालना. So this is all in the today class, right? इन सबका आपको molecular mass वगैरह निकालना है. So ये हम लोगों ने डिस्कस किया. कल फिर मिलेंगे. And in tomorrow class also we are going to solve some more numerical related to the mole concept, limiting reactant and the concentration defining term as well. Right? We'll take care all.